Hey, what's up, Logic fans? It's Ash. This is video 4.4D, our fourth video on the meaning of the Universal Quantifier. And I'm going to take some time just in this video. I wasn't planning on doing this, but a lot of students are saying that they really find going through these sentences this way very helpful. So I'm going to do on this video just some more of that. So if you feel like you've got it and you want to skip that, that's fine. Otherwise, I'm going to do some more examples here. And what I want to do is I want to look at a one of the more difficult examples we looked at in one of the previous videos and do a deep dive on that. So let's go ahead and look at this particular case. Now, what's interesting here is that we've got an individual constant baked into, this quantifier sort of ranging over this whole construct here, and includes the individual constant here. And so, what we're going to have to do for this case is we're going to have to think about, all right, this B being fixed here. So the only thing that's sort of changing throughout, again, if we have three individual constants, A, B, and C, then the idea is that everything that is A, B, and C has to satisfy this description. So A has to be this way, B has to be this way, and C has to be this way, and this just sort of stays fixed. And so provided that all three of these are true, this whole thing is true, right? If one of these is false, then this whole statement, universally quantified statement here, is false. So let me give you a case to think about. Let's suppose that HA is true and JB is false, for example. What would be the truth value then of this statement? Pause now. Okay, so if HA is true, then we would have true arrow JB being false. True arrow false is a false conditional, and since this has to hold of everything, we know right there that this universally quantified statement is thereby false. All right. Let's try another one here, which is let's try something like this, just to see how you do with it. Okay, so let's take a look at a sentence like this, and let me give you a domain to think about for this one. So let's suppose you have a domain with three objects, A, B, and C. All right, and A has the property F, but B and C both lack the property F. So assuming that, is this statement true or false? Pause now and we'll go through it together. Okay, hopefully you've had a chance to pause and think on this. Okay, but this statement is actually going to be false. So my first question for you is, what is the main connective of this sentence? What is its fundamental type? Is this a negation? Is it a universally quantified sentence? What is it? All right, so this is a disjunction, right? If you don't understand that, make sure you go back and look very carefully at 4.2 and 4.3, okay? So this is a disjunction. That means the fundamental truth table we're going to apply is that. And this is the left disjunct, and this is the right disjunct. So at least one of these has to be true in order for it to be true. Let's go ahead and evaluate the left disjunct really quickly, okay? Well, the left disjunct says that everything that is A, B, and C in our domain, okay, has to satisfy this description. So it's got to be, this has to be true, this has to be true, and this has to be true, right? And so if we look at that, what happens? Well, this one is true, but these two are false. So the left disjunct is false, all right? Let's go ahead and take a look at the right disjunct. Okay, the right disjunct says that everything has to satisfy this description. So every single one of these statements is going to have to be true, all right? And do we notice that all of these are true? Well, these two are true, but this one, okay, this one here is false. And since it has to be for everything, this statement here is going to be false. So you got false or false, and so the whole thing is false. Notice this says either everything is a certain way or everything is this certain way. Okay, and I want to contrast that with, let's go ahead and take, let's contrast that with this statement as an example. Okay, so these two statements are quite different, all right? Let's go ahead and take a look at this one, and we're going to use the same domain in order to prove this, okay? So this statement here, let's go ahead, let's drop it down here, all right? This is the one we're going to analyze, all right? So this statement here says that everything in my domain, A, B, and C, has to satisfy this description. So let's go ahead and get this description on the board, all right? So A's got to satisfy this description. So A has to be this way, B has to be this way, and C has to be this way. All right? And so now we just have to go through and check, you know, is it the case that everything satisfies this description? So check it out. Well, A either has F or lacks F. That's true, right? B either has F or lacks F. That's also true. And C either has F or lacks F. That's also true, right? And so since every single one of these is true, it's true that everything satisfies this description, and therefore this statement is in fact true, okay? So these are very different statements that mean different things, and I hope I've convinced you of that, all right? This says everything satisfies this description. Either it's F or it's not F. For anything you pick out of Santa's bag, pick anything you like out of there at random. That thing you picked out, it will be this way. Either it will be F or it's not the case that it's F. Okay? And that's actually should remind you of a tautology, okay? In some respects. And so this ends up being a true statement. Now, this statement here is quite different. This says either everything in my domain of discourse has the property F, or everything in my domain of discourse lacks the property F, so there can't be any mixing. So for example, if everything were this way, then this statement would be true, and therefore the disjunction would be true. Similarly, if it were like this, then this statement would be true, and therefore the entire disjunction would be true. Okay, but instead we had it like that, and so this fails in this situation. Okay. All right, I hope that's helping. Let's do one more here for practice sake. All right, let's try this one, and this one has the biconditional baked into it, so we'll do a deep dive on this guy. Here's your domain, okay? You've got your two property constants, ky and gx, and you've got three objects, a, b, and c, and b has the property k and lacks the property g, and a lacks the property k and has the property g, and so on, okay? And you're supposed to determine whether this universally quantified sentence is true or false on this domain. I'm going to give you a hint in a second, but pause now and see if you can figure it out. Okay, hopefully you've had a chance to pause and think on this on your own, but let me go ahead and give you a hint, and then I'll give you another opportunity to solve it. All right, so your hint is that since this says everything in domain, that is A, B, and C, has to satisfy this description, then A has to be this way, B has to be this way, and C has to be this way. So there's your hint. See if you can evaluate these statements, right? And this statement is true provided all three of these are true, and this statement is false provided at least one of these is false. Pause now. Okay, so hopefully you've had a chance to pause and think on this for yourself. So let's go ahead and take a look at this. Now, A lacks the property K, so this turns out to be false, all right? This is a false statement, right? And then not GB turns out to be a true statement, all right? So not GB is true, so this is a false true statement. And since we've just evaluated not GB as true, we can just go ahead and fill it in here all the way down. For practice, let's evaluate KB. KB turns out to be true, and KC turns out to be false. All right, so false. So in this case, it turns out the biconditional turned out to be true, but in these two other cases, it was both false. So in this particular domain, this statement is false. Okay, And that's the basics of how we're evaluating these statements. Okay, so that's it for these types of deep dives. There's plenty of practice problems in the book. On the next video, also on 4.4, so it'll be 4.4e, I'm going to teach you about the empty domain, so don't miss that.